Hey class, happy Monday to you following the Super Bowl. We're doing 11-4 quadrilaterals. Last week, quick reminder, we got done doing triangles and congruent triangles. So we'll build off of that to quadrilaterals and see how they're related. So again, take your notes of the highlighted words. First word, quadrilateral. It's a closed figure with 4 sides and 4 angles. So you see down here we have some examples of quadrilaterals and not quadrilaterals. A couple of additional things to point out. They have to be line segments. They can't have curves. They can't intersect anywhere except for their endpoints. So here we have a quadrilateral. There's 4 sides and 4 angles. 4 sides, 4 angles. It's a little goofier, but again, we have 4 sides, 1, 2, 3, 4, and 4 angles. These ones are not quadrilaterals. We'll start here. This one intersects in the middle of the 2 lines, so not quadrilateral. Here we have 1, 2, 3 sides, but this 4th side is curved. That's not possible. It has to be a straight line segment. And this last one has 5 sides. So quadrilaterals have to have 4 sides in them. We list the vertices and everything the same way as triangles. So the sides are 2 letters. So we have side AB, side BC, side CD, and side DA. The vertices are the corners, A or B, C or D. And the angles are again the vertices, but we put an angle sign in front if we're talking about an angle. So angle A, angle B, angle C, angle D. And we usually put loops if we're talking about the angles like that. Alright, now here's a big rule right here we're going to use mostly today is all the angles in a quadrilateral will add up to 360 degrees. Well, why is that? Well, if I look at a quadrilateral here and I cut it from 2 corners that are opposite each other, so A to C, I have 2 triangles here. This triangle, I'll put a little 1, and this triangle 2. Okay, and we talked about the other week, triangles add up to how many degrees inside of them? 180. So this triangle will add up to 180. This triangle over here also adds up to 180. Together, 180 plus 180 is 360 right there. So if you take all the angles in the corners or in the vertices of each quadrilateral and add them together, they will always add up to 360 degrees. So A plus B plus C plus D, all the angles will add up to 360. That's a very important rule. That's what we're going to use today for most of the assignment and see what we can do with that. So let's see how we can solve some problems when we are missing some numbers. Let's look at this quadrilateral up here. Okay, I want to find out how many degrees are an angle X, or what's the value of X. So if I look, here's an angle, 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 angle. Quadrilateral, how many degrees do we just say quadrilateral adds up to? 360. So let's add up all the angles and set it equal to 360. Let's start in this corner right here. So X plus, let's go to this corner right here, X plus 7. Plus this corner right here. How many degrees are in this corner when they put a little square? That's 90 degrees. And then our last angle is 75. All 4 of those angles have to add up to 360 degrees. Okay? So now it's an equation that we have to solve. It looks like a pretty complicated one because it's long, but we don't really need these parentheses here because we're just adding everywhere. So we're going to combine our like terms and see what it looks like. So what is X plus X? Well, that is 2X. If I add up these 3 numbers here, 7 plus 97 plus 75 is 172. I did that in my head, I hope that's right. Equals 360. And now it's a 2-step equation that we've solved before. I want to get X by itself. So my first thing I'm going to do is subtract 172 from both sides because I want to get rid of that plus 172. So that's gone. What I do to one side, I do to the other side. So 360 minus 172 leaves me with 2x equals, let's see, 188. Sound right? I think so. And then how do I solve this final step? What do I do to get rid of this 2? Well, this is like 2 times x. So the opposite or the inverse is divide by 2. Divide by 2. So my final answer, x equals 94. So the missing angles are 94 and 101, because I have to add 7 in that corner. Alright, quick look at the guided practice here, just setting it up. Again, has to add up to 360, right? Well, then I add up all 4 corners. X, 3x, 70, and 82. Those 4 have to add up to 360 every single time we have a quadrilateral. And now I combine my like terms. What is x plus 3x? That's 4x. 70 plus 82, 152. And now it's exactly the same as the problem above. I'm going to subtract 152 from both sides and then divide by 4. So I do 360 minus 152, divide by 4, I get a value of 52 degrees. Alright, that's how we do these problems. We always set them equal to 360, we combine our like terms, and we solve an equation. That's why it's so important to solve equations earlier on. They're going to keep coming back the rest of the year. Okay, copy down this chart. Got to have this chart copied down in your notes. It's very important to classifying quadrilaterals. So all these in this picture are quadrilaterals. There's specific qualities about each one. Let's talk about trapezoid first, because it's kind of all by itself over here. There's only one line to it. Trapezoid is unique because it only has one pair of parallel sides. Now, those are called the bases. We'll get into that more when we talk trapezoids in depth, but has one pair of parallel sides. It's kind of unique because everything else in this picture has 2 pairs of parallel sides. So one pair is parallel, the other sides are not parallel. Parallelogram, well, parallelogram means all the opposite sides are parallel. Additionally, they're also congruent. So this side here and this side here are parallel. They're also going to be the same length in a parallelogram. Okay, this side here and this side here are parallel. They're also going to be the same length as each other. Now we break off. All these down here are also parallelograms, so they have all of those same qualities, but they have one extra thing. Alright, so let's look at a rectangle first. Rectangle, the opposite sides are parallel and the same length. There and there, there and there. The additional rule is rectangles have to have right angles in them. So a rectangle is a parallelogram, it just also has right angles. A rhombus is also a parallelogram. These opposite sides are parallel. The opposite sides are congruent, but all 4 sides are going to be congruent. So they're all 4 are going to be the same measure. You're used to seeing that in what's called a square, but we do not necessarily have right angles like a square down here. So a square is a combination of a rectangle and a rhombus together. I guess and a parallelogram. Rhombus means it has all 4 sides are the same. Rectangle has 4 right angles. You combine them together, you get a square. So square is kind of all of this combined into one figure. It's a parallelogram, a rectangle, and a rhombus. So let's work on classifying these. Here's a free throw line they use in the International Basketball Federation. Notice when they're lined up, it's not straight like we're used to in our high school basketball. They have a little slant to them. So what kind of figure is this? Just classify it. Well, the free throw line is parallel to the baseline, so that's one pair of parallel sides. But these sides here are not parallel. Okay? If you extended them, they will run into each other eventually. So if it has one pair of parallel sides, that tells me it's got to be a trapezoid. Look at this one down here. What do you think this one's going to be classified as? Well, if it's a trapezoid, that means there's one pair of parallel sides, so I don't see any sides that are parallel. And everything else we talked about has to have two pairs of parallel sides. So the most basic classification is just a quadrilateral. It has four sides, so it is a quadrilateral, but nothing more than that. Alright, thank you for your time. Have a wonderful, wonderful Monday.